So at this time, I would like to present Dr. Peter Lindemann.
Thank you, Nola. And thank you all for being here tonight. As you know, this is a private invitation kind of party. And I've been involved in free energy research for about 27 years. And we'll begin tonight where I started back in 1973. Without doing too much other introduction, I'd like to start the process. If we could bring down these lights also. My life changed in the summer of 1973 when I first picked up the National Tattler. In an article authored by reporter Tom Valentine, the headline read, "Man creates engine that consumes no fuel. Invention could change history by 1984. Well, I was young and gullible, but I'd sure never seen a newspaper headline like that before. The article went on to say, a California inventor has found a way to create limitless electric power without using up fuel, potentially the greatest discovery in the history of mankind. Edwin Gray Sr., 48, has fashioned working devices that could power every auto, train, truck, boat, plane that moves in this land perpetually, warm, cool, and service every American home without erecting a single transmission line, feed limitless energy into the nation's mighty industrial system forever, and do it all without creating a single iota of pollution." Well, these are certainly the things that dreams are made of. After discussing a number of things, including the difficulty of raising capital and bringing a working team together, this article goes on to discuss two very interesting tests. What I would like to do is read to you from this article to begin to create the understanding of what this technology is. Reading again from the article, the Tattler was given a thorough demonstration of Gray's impossible but true methods for using electricity. The first demonstration proved that Gray was using a totally different form of electrical current, a powerful but cold form of energy. A 6-volt car battery rested on a table. Lead wires from the battery to a series of capacitors, which are the key to Gray's system. The complete system was wired to 2 electromagnets, each weighing 1.25 pounds. Now, if you tried to charge these magnets with juice from that battery and make them do what I'm going to make them do, you would drain that battery in 30 minutes and the magnets would get extremely hot, Gray explained. I want you to watch what happens. As Fritz Lenz activated the battery, a voltmeter gradually rose to 3,000 volts. At that point, Gray closed a switch and there was a loud popping sound. The top magnet hurled into the air with tremendous force and was caught by Richard Hackenberger. And as you can see right here, this is the magnet after it's been popped up. A terrific jolt of electricity had propelled the top magnet more than 2 feet into the air, but the magnet remained cold. The amazing thing, Hackenberger said, is that only 1% of the energy was used and 99% went back into the battery. The battery can last for a long time because most of the energy returns to it. The secret to this is in the capacitors and in being able to split the positive. When Gray said split the positive, the faces of 2 knowledgeable physicists skewed up in bewilderment. Normally, electricity consists of positive and negative particles, but Gray's system is capable of using one or the other separately and effectively. The next demonstration begins a few paragraphs down. I'll change the slide here. Gray showed this Tattler reporter a small 15-amp motorcycle battery. And by the way, these photographs have never been seen before. They're part of the personal archive of Tom Valentine. It was hooked to a pair of his capacitors, which in turn were hooked to a panel of outlets. He flicked a switch and a tiny battery sent a charge into the capacitors. Then he plugged in 6 15-watt electric light bulbs on individual cords. Unfortunately, the light bulbs are off the screen there, but you can see the cords and the plugs. 110-volt portable television set and 2 radios. The bulbs burned brightly, the television played, and the radios blared, and yet the small battery was not discharging. You couldn't begin to get all this current out of that battery under ordinary circumstances, Gray said. "This is the most amazing thing I've ever seen," exclaimed C.V. Wood, Jr., president of the McCulloch Oil Corporation. He began looking around for hidden outlets from the wall. "May I prove it doesn't come from any wall plug?" Gray offered. A 40-watt light bulb screwed into an ordinary extension socket was plugged into Gray's system. The bulb lit, then Gray dropped it into a cylinder filled with water. "What would be happening if this was getting ordinary power right now?" Gray asked as he stuck his hand in the water with the glowing light bulb. "You'd be electrocuted and that thing would be popping and sputtering until the fuses blew," Wood replied. This reporter then stuck his finger into the water with the light. No shock. And that's Tom Valentine right there with his finger in the water. "Gentlemen, this is a new manifestation of electricity," Hackenberger said. Well, this was quite literally the most amazing thing I'd ever read in a newspaper. I was completely hooked. The next week, I picked up the second article in the series. Here it is. It says, "Miracle no-fuel electric engine can save the public $35 billion a year in gasoline bills." Talks about this amazing new type of electric motor that runs on Gray's system. Here it says, "The silent, pollution-free EMA motor recycles its own energy and can run indefinitely. Gray's prototype is powered by 4 6-volt batteries, which will wear out before they run down." Again, here it says, "The same cold energy repelling magnets arranged on a flywheel run the motor." Hackenberger, an electronics specialist, explained, "A series of high-voltage energy spikes are developed in our circuitry. These energy units are transferred to a control unit, which acts much like a distributor in the internal combustion engine. Every time a magnet is charged, most of the energy is recycled back to the batteries without losing power." These two articles, which I ran into when I was 22 years old, completely captivated my imagination. I started talking to my friends about it, and a few months later, my brother and I wrote to Ev Gray Enterprises, expressing our interest and desire to have more information. Here's a copy of the letter I got back from them in October of 1973. It says, "Dear Mr. Lindemann, we'd like to thank you for showing such interest in Ev Gray Enterprises and for taking the time to write to us. I've also sent a letter to your brother. But due to our security, we are unable to give out any information about our motor or company." Well, that was disappointing. So these two newspaper articles and this letter went into a file. And this was the beginning of my now rather extensive free energy files. Remarkably, these were the only 2 issues of the National Tattler I ever saw. At about that same time, another article came out in a magazine called Probe the Unknown, authored by Jack Scagnetti, called Engine That Runs Itself. And again, it contains very similar kinds of information as the articles by Tom Valentine. In one section, it says, "Gray describes the operation of his EMA motor as similar to recreating lightning." And again, here it says, "Richard Hackenberger, Vice President in Engineering of Ev Gray, explains how the EMA motor system operates. Power from the high voltage section is put through a system of electrical circuitry to produce a series of high voltage energy spikes. The spikes are transferred to a control unit, which in turn operates the motor unit. While this occurs, The recycle regeneration system is recharging the battery with 60 to 100 amp pulses. Now that's impressive. Beyond that, I didn't see anything on Ed Gray for a couple of years. Next thing that came out was this magazine by Tom Valentine called Newsreel. This issue is on a series of suppressed inventions. In here he talks about a wide variety of things, from making oil from coal, making gasoline from water, airplanes that won't stall, and all kinds. Well, so here's another update article on Ed Gray. It's called EMS, Electronic Power That Can Change the World's Economic Picture. Here again is another very interesting set of quotes. On page 2 of the article, Gray says, "I remember getting a shock when I grabbed a capacitor off a workbench. That simple fact never left my mind. Then I watched when the government people were testing the first radar across the Potomac River. It stuck in my mind when one of the men explained it as pulse out, pulse back. And I've always been a nut about thunderstorms. I would watch lightning by the hours. I noticed how much stronger it appeared to be when closer to the earth, and just naturally concluded that the more air had something to do with it. These three principles, plus a super secret means of generating and mixing static electricity, make up Gray's EMS motor." And again, later in the article, there's this. "There's no motor like this in the world," Dr. Chalfin told the group. "Ordinary electric motors use continuous current and constantly drain power. In this system, energy is used only during a small fraction of a millisecond. Energy not used is returned to an accessory battery for reuse. It is cool running." Dr. Chalfin added, putting his hand on the motor, "There is no loss of energy in the system." Gray's first patent issued in June of 1975, titled Pulsed Capacitor Discharge Electric Engine. I got my first copy of this patent in 1978. It's a rather extensive patent with 18 pages, 19 illustrations, and 18 claims. It describes an engine that runs by discharging capacitors through electromagnets that oppose each other. I'm sure that most of you have guessed by now that if you try and build this motor according to the principles outlined in this patent, it does not perform anything like what these articles are talking about. And in fact, it does not produce a cold form of electricity. So if you get into the discharge path of those capacitors, it'll throw you across the county. What's more, the amount of energy that you can recycle from this arrangement is negligible compared to what Gray is talking about in these articles. So it became obvious to me quite quickly that in spite of the fact that this patent reveals a great deal about the mechanical arrangements of the motor, it does not reveal the technique of its operation. I was always more interested in the solid-state circuit anyway. I realized that the production of cold electricity really had nothing to do with the motor, that the motor was a secondary event. After all, when Gray was popping the magnets with cold electricity, or running the TV and the light bulbs on cold electricity, he didn't need the motor. So it always stuck in the back of my mind that I wanted to understand the solid-state circuit. That was what was important to me. So by the late 70s, I had pretty much exhausted all the information that was available. By the late 1980s, I heard a few rumors that suggested that Gray had been working with the military. But all I knew was essentially that he'd just disappeared. No more news articles or anything else ever appeared about him. Time continued to pass, and by the mid-1990s, another research associate of mine told me that he had heard that Gray had been issued other patents. Now, this was completely intriguing to me, and I knew at some point I needed to get a hold of these documents. But he didn't have them, and he didn't know what the numbers were, and unfortunately, that also turned out to be a dead end in my research. Finally, last summer, in June of 1999, I was on the IBM intellectual property site on the internet, and I noticed that they had just recently updated their search engines within the patent database. For those of you who are not familiar with this database, they have every U.S. patent from 1971 forward online. It was now possible to restrict the search to just the inventor line. And of course, if you plug the word gray into a search and look at every word in every patent from 1971, you get so many hits you can't go through it. But when you could plug in just gray, Edwin into the inventor line in this newly updated search engine, I thought, well, I'll just see what happens. 30 seconds later, the numbers of the two other patents that had issued to Ed Gray came on my screen. I was ecstatic. Here's the first one. Issued in June of 1986, called Efficient Power Supply Suitable for Inductive Loads. This is by far and away one of the most astonishing and important circuits that I had ever seen. Understanding this patent will be the primary focus of the talk this evening. The other patent that issued came approximately 10 months later, in April of 1987. It is called Efficient Electrical Conversion Switching Tube, Suitable for Inductive Loads. These two patents are very closely linked and are almost identical. One of them talks about the circuit that drives this switching tube, and the other one talks about the switching tube itself. About 5/6 of the wording in both of these patents are identical, word for word, paragraph after paragraph. So here is the circuit diagram for the first one. Now we can finally see what Gray was really doing. I had searched 26 years for this diagram. I felt sure that it was the basis of his cold electricity circuits. But Gray was still holding his cards quite close to his chest. Even though the diagram is sitting here, it is not clear how these components behave or what they do or why. The more I studied the text, which is relatively short compared to the motor patent, the more I realized I was looking at something that was really quite foreign to me. Intuitively, I felt I had all the pieces, but I still didn't know how the pieces went together or what the picture looked like. Why was this circuit able to create free energy? There were still far too many unknowns. I was heartened, though, by many of the things that are stated in the patent. Here's one small section. Quote, "There is disclosed herein an electrical driving system which, on theory, will convert low-voltage electrical energy from a source, such as an electric storage battery, to a high-potential, high-current energy pulse that is capable of delivering a work force at the inductive output of the device that is more efficient than that which is capable of being developed directly from the energy source." Now that statement may sound a bit obscure, but actually it's a pretty sneaky way of saying free energy. And again down here, it says, "This system accomplishes the results stated above by harnessing the electrostatic or impulse energy created by a high-intensity spark generated within a specially constructed electrical conversion switching element tube. This element utilizes a low-voltage anode, a high-voltage anode, and one or more electrostatic or charge-receiving grids. These grids are of a physical size and appropriately positioned as to be compatible with the size of the tube, and therefore directly related to the amount of energy to be anticipated when the device is operating." As I continued to read this patent, I was also intrigued by these components here, number 44, number 42, and number 46. Just let me read what the patent says about these. It says, a spark gap protection device, 42, right here, is included in the circuit to protect the inductive load and the rectifier elements from unduly large discharge currents. Should the potentials within the circuit exceed predetermined values, fixed by the mechanical size and spacing of the elements within the protective device, the excess energy is dissipated or bypassed by the protective device to the circuit common, the electrical ground. And again here it says diodes 44 and 46 bypass the excess overshoot generated when the energy conversion switching tube is triggered. So here we have three elements in this circuit which are specifically designed simply to dump excess energy when this tube fires. This sounds like there's the possibility of producing so much energy here that it can damage the rest of the circuit. Well, that was quite promising, but we still didn't really know why that would happen. We didn't understand what was going on. Apparently, something extremely large happens when this conversion switching tube fires. This is obviously the secret of the device. So I was sure I had discovered it. But what I still didn't know what I was looking at. I didn't know why that thing would do what he says it does. I kind of needed a Rosetta Stone. Something that would translate all of these unknowns into an understandable context. Luckily, I found it. That Rosetta Stone is a book called Secrets of Cold War Technology, Project HARP and Beyond, written by Jerry Vassalatos. In Chapter 1, titled Nikola Tesla and Radiant Energy, Jerry recounts those heady days back in 1890, when Nikola Tesla is developing the experiments which lead to the invention of Tesla's magnifying transmitter. For those of you who have not seen this book before, I highly recommend that you acquire and read the entire book. It is an astonishing work, currently available from Adventures Unlimited Press. But for the purposes of tonight's thesis, I would like to read for you selected sections from Chapter 1, which will lay the foundation for you to completely comprehend Tesla's amazing magnifying transmitter, as well as Gray's cold electricity circuit. My recital begins on page 25 of Secrets of Cold War Technology by Jerry Vassalatos. James Clerk Maxwell predicted the possibility that electromagnetic waves might exist. In theoretical discussions designed to more thoroughly explain his mathematical descriptions, Maxwell asked his readers to consider two different kinds of electrical disturbance possibly existing in nature. The first consideration dealt with longitudinal electric waves, a phenomena which required alternating concentrations of electrostatic field lines. This densified and rarefied pulsation of electrostatic fields necessarily demanded a unidirectional field, one whose vector was fixed in a single direction. The only variable permitted in generating longitudinal waves was the concentration of the field. Subsequent propagation along the electrostatic field lines would produce pulsating thrusts of charge, pulsations moving in a single direction. These electrical sound waves were rejected by Maxwell, who concluded that such a condition was impossible to achieve. His second consideration dealt with the existence of transverse electromagnetic waves. These required the rapid alternation of electrical fields along a fixed axis. Space-spreading electrical lines would supposedly bend to and fro under their own momentum, while radiating away at the speed of light from the alternating source. Corresponding forces, exact duplicates of the alternations produced at the source, would be detected at great distances. He encouraged the experimenters to seek this waveform, suggesting possible means for achieving the objective. And so the quest to find electromagnetic waves began. In 1887, Heinrich Hertz announced that he had discovered electromagnetic waves, an achievement at that time of no small import. In 1889, Nikola Tesla attempted the reproduction of Hertz's experiments. Conducted with absolute exactness in his elegant South Fifth Avenue laboratory, Tesla found himself incapable of producing the reported effects. No means, however applied, would produce the effects which Hertz claimed. Tesla began experimenting with abrupt and powerful electric discharges, using capacitors charged to very high potentials. He found it possible to explode thin wires with these abrupt discharges. Dimly perceiving something of importance in these experiments, Tesla abandoned these experiments, all the while pondering the mystery and suspecting that Hertz had somehow mistakenly associated electrostatic inductions or electrified shock waves in air for true electromagnetic waves. In fact, Tesla visited Hertz and personally proved these refined observations to Hertz, who, being convinced that Tesla was correct, was about to withdraw his thesis. Hertz was truly disappointed, and Tesla greatly regretted having to go to such great lengths with such an esteemed academician in order to prove his point. But while endeavoring toward his own means for identifying electrical waves, Tesla was blessed with an accidental observation which forever changed the course of his experimental investigations. In his own attempts to achieve where he felt Hertz had failed, Tesla developed a powerful method by which he hoped to generate and detect real electromagnetic waves. Part of this apparatus required the implementation of a very powerful capacitor bank. This capacitor battery, as he called it, was charged to a very high voltage and subsequently discharged through short copper bus bars. The explosive bursts thus obtained produced several phenomena which deeply impressed Tesla, far exceeding the power of any electrical display he had ever seen. These proved to hold an essential secret which he was determined to uncover. The abrupt sparks, which he termed disruptive discharges, were found capable of exploding wires into vapor. They propelled very sharp shock waves, which struck him with great force across the whole front of his body. They propelled very sharp shock waves, which struck with extreme force. Of this surprising physical effect, Tesla was exceedingly intrigued. Rather more like shotguns of extraordinary power than electrical sparks, Tesla was completely absorbed in this new study. These electrical impulses produced effects commonly associated only with lightning. The explosive effects reminded him of similar occurrences observed with high-voltage DC generators. A familiar experience among workers and engineers, the simple closing of a switch on a high-voltage dynamo often brought a stinging shock, the assumed result of a residual static charging. This hazardous condition only occurred with the sudden application of high-voltage DC. This crown of deadly static charge stood straight out from highly electrified conductors, often seeking ground paths, which included workmen and switchboard operators. In long cables, this instantaneous charge effect produced a hedge of bluish needles, pointing straight away from the line into the surrounding space. The hazardous condition appeared briefly at the very instant of switch closure, The bluish, sparking crown vanished a few milliseconds later, along with the life of any unfortunate who happened to be so struck. After the brief effect passed, the systems behaved as designed. Such phenomena vanished as charges slowly saturated the lines and systems. After this brief surge, current flowed smoothly and evenly as designed. The effect was a nuisance in small systems, but in large regional power systems where voltages were excessive, it proved deadly. Men were killed by the effect, which spread its deadly electrostatic crown of sparks throughout the component systems. Though generators were rated at a few thousand volts, such mysterious surges represented hundreds of thousands, even millions of volts. The problem was eliminated through the use of highly insulated, heavily grounded relay switches. Former engineering studies considered only those features of power systems which accommodated the steady-state supply and consumed power. It seemed as though larger systems required both surge and normal operative design considerations. Accommodating the dangerous initial supercharge was a new feature. This engineering study became the prime focus of power companies for years afterwards, safety devices and surge protectors being the subject of many patents and texts. Tesla knew that the strange supercharging effect was only observed at the very instant in which dynamos were applied to the wire lines, just as in his explosive capacitor discharge. Though the two instances were completely different, they both produced the very same effects. The instantaneous surge supplied by dynamos briefly appeared super concentrated in the long lines. Tesla calculated that this electrostatic concentration was several orders of magnitude greater than any voltage which the dynamo could supply. The actual supply was somehow being amplified or transformed. But how? The general consensus among engineers was that this was an electrostatic choking effect. Many concluded that it to be a bunching action where powerfully applied force was unable to move charge quickly through a system. Mysterious, the combined resistance of such systems seemed to influence the charge carriers before they were able to move away from the dynamo terminals. Like slapping water with a rapid hand, the surface seemed solid. So it was with the electrical force, charges meeting up against a seemingly solid wall. But the effect lasted only as long as the impact. Until current carriers had actually caught up with the applied electrostatic field, the charges sprang from the line in all directions. A brief supercharging effect could be expected until charges were distributed, smoothly flowing through the whole line and system. The dynamo itself thus became the brief scene of a minor shock wave. He began wondering why it was possible for electrostatic fields to move more quickly than the actual charges themselves. A perplexing mystery. Was the field itself an entity which simply drove the more massive charges along? If this was true, then of what was the electrostatic field itself composed? Was it a field of smaller particles? The questions were wonderfully endless. Despite the wonderful ideas which this study stimulated, Tesla saw a practical application which had never occurred to him before. Consideration of the dynamo supercharging effect suggested a new experimental apparatus. It was one which could greatly outperform his capacitor battery in the search to find true electrical waves. A simple high-voltage DC generator provided this electrical field source. Tesla understood that the resistance of the lines, or components, viewed from the dynamo end, seemed to be an impossible barrier for charge carriers to penetrate. This barrier caused the bunching effect. Electrostatic charges were literally stopped and held for an instant by the line resistance. a barrier which only existed during the brief millisecond interval in which the power switch was closed. The sudden force application against this virtual barrier squeezed charge into a density impossible to obtain with ordinary capacitors. It was the brief application of power, the impact of charge against the resistance barrier, which brought this abnormal electrodensified condition. This is why the conductive wires in his present experiment often exploded. The analogy to steam power and steam engines was unmistakable. Large steam engines had to be valved very carefully. This required the expertise of old and well-experienced operators who knew how to open up an engine without rupturing the vessels and causing a deadly explosion. Too suddenly valved, and even a large steam engine of very high capacity could explode. Steam also had to be admitted into a system gently until it began smoothly and gradually flowing into every orifice, conduit, and component. Here, too, was the mysterious choking effect, where a large capacity system seemed to behave like an uncommonly high resistance to any sudden and sustained application of force. The academic world of experimenters was yet fixated on his former discovery of high-frequency alternating currents. It seemed that Tesla alone now exclusively studied these impulse discharges. He was producing explosive impulses which had not been observed in laboratories. Every component was carefully insulated, himself implementing insulated rods and rubberized regalia to ensure complete safety. Tesla had observed electrostatic machines whose ability to charge insulated metals was potent, but this demonstration exceeded the mere charging of wires by the instantaneous switch closure. This effect produced springing charge, phenomena like no other before witnessed by Tesla for its sheer strength. Whatever the conditions observed in previous systems, he had now learned how to maximize the effect. Balancing voltage and resistance against capacity, Tesla learned to routinely produce supercharged states which no existing device could equal. Empirical observation had long taught that ordinary capacitor discharges were oscillating currents, spark currents which literally bounced back and forth between the capacitor plates until their stored energy was wasted away. The high voltage of the dynamo exerted such an intense unidirectional pressure on the densified charges that alternations were impossible. The only possible backrushes were oscillations. In this case, charges surged and stopped in a long series until the supercharge was wasted away. All parameters which forced such oscillations actually limited the supercharge from manifesting its total energetic supply, a condition which Tesla strove to eliminate. Indeed, he spent an excessive time developing various means to block every backrush and other complex current echo which might force the supercharge to prematurely waste its dense energy. Here was an effect demanding a single unidirectional superpulse. With both the oscillations and alternations eliminated, new and strange effects began making their appearance. These powerful and penetrating phenomena were never observed when working with high-frequency alternations. The sudden, quick closure of the switch now brought a penetrating shock wave throughout the laboratory, one which could be felt both as a sharp pressure and a penetrating electrical irritation, a sting. Face and hands were especially sensitive to the explosive shock waves, which also produced a curious stinging effect at close range. Tesla believed that material particles approaching the vapor state were literally thrust out of the wires in all directions. In order to better study these effects, he poised himself behind a glass shield and resumed the study. Despite the shield, both shock waves and stinging effects were felt by the now mystified Tesla. This anomaly provoked a curiosity of the very deepest kind, for such a thing was never observed before. More powerful and penetrating than the mere electrostatic charging of metals, this phenomena literally propelled high-voltage charge out into the surrounding space, where it was felt as a stinging sensation. The stings lasting for a small fraction of a second, the instant of switch closure. But Tesla believed that these strange effects were a simple effect of ionized shock waves in air, rather like a strong ionized thunderclap. Tesla devised a new series of experiments to measure the shock wave pressure from a greater distance. He required an automatic trip switch. With this properly arranged, a more controlled and repetitious triggering of the effect was possible. In addition, this arrangement permitted distant observations which might cast more light on the shield penetrating phenomenon. Controlling the speed of the high-voltage dynamo controlled the voltage. With these components properly adjusted, Tesla was able to walk around his large gallery spaces and make observations. Wishing also to avoid the continuous pressure barrage of its stinging sparks, Tesla shielded himself with several materials. The arrangement of rapidly interrupted high-voltage direct currents resulted in the radiation of stinging rays,